All right, so let's see if we can get through this one as fast as possible. We are on section 3. Discrete and continue. Man, that's small, right? Continuous random variables is where we're looking at. All right, here we go and begin. Okay, so let's say we flip a coin 3 times. Now, if you flip a coin 3 times, you either have heads or tails come up for each one. Here is the sample space for that. There are 8 total outcomes that you can have. They're listed there. Okay. So what's the probability of any of those outcomes occurring? They would be 1 in 8 because there's 8 total and each one have the same probability of each one. Okay. So now let's say X represents the number of heads out of the 3 tosses. So 0 heads, it was 1 out of 8 because there's only one of those 8 possibilities where they're only tails. Next one is if there's only 1 head. So you see there's 3 options. Okay. They're all on that bottom row. 2 heads for it, and there are 3 options. They are on that first row. And if all 3 of them are heads, there's only 1 of them, because since there's only 1 that are all tails, and there would be only 1 that are all heads. Okay, so those are your probabilities for each one. Okay, so that's showing that distribution. Now, from there, we can take that and we can find the probability of each part. Okay, so the probability of X is equal to 2, so if 2 are heads, would be 3 out of 8. Now, we can also take the probability of if X is greater than or equal to 2, which would mean we would take the probability of 2 and the probability of 3 and any other ones that are higher, but since 3 is the max we could have, we would just take those 2 and add them together. 3 over 8, 1 over 8, added together gets us 4 over 8, which is a 1/2 or a 0.5. Okay. If we wanted to go less than, so if it was less than 2, we would do 0 and 1. We wouldn't include the 2 if we were not including the 2, if it was just less than 2, and not less than or equal to. Okay, so random variables. Now, numerical values that describe the outcome of some chance process. Okay, these are usually capital letters. Okay, random variables can be discrete or continuous, and they must have a numeric value. Okay, so they must have a numeric value for those, and we're going to go through and looking at these. So we're going to start off looking at discrete, and then we're going to turn into continuous. Okay, so discrete random variables, basically the number has to be a fixed number, 1, 2, 3, 4, 5. So the example that we just did would be an example of a discrete. Okay, these make your nice little bar graphs if you wanted to make a bar graph of it because it's each section. They're usually not decimals, and we can skip over numbers. So it doesn't have to be 1, 2, 3. It could be 1, 2, 4. Okay. And you can have decimals, but for the most part, we usually keep these as nice whole numbers. If they are decimals, a lot of people like to multiply it up to get rid of decimals because decimals are messy. The probability must satisfy 2 requirements. Each probability must be between 0 and 1, and the sum of the probabilities must be 1. Because if the entire sample space is not equal to 1, then it's not the entire sample space, because an entire sample space must be 100%. And if not all of them are there, then you cannot have the entire sample space. Okay. So let's do an example of if we pick a letter from the alphabet out of a hat. If you choose a consonant, I will pay you $1. If you choose a vowel, then I pay you $5. Question is, basically, what's the distribution look like? Well, X is the numbers, and it's either a 1 or a 5. That's how much I pay you. So I either pay you $1 or I pay you $5. The probability of it being 1 would be 21 out of 26. Y is not a vowel in this case. And the other one would be 5 out of 26. Okay, and that's just making your distribution table. From there, we can find the mean, standard deviation. We can find all this stuff from it. But right now, we're just focusing on, at this point of the video, we are focusing on making the distribution table. Now, the second type here is continuous. So the continuous random variable means that you take all possible values into account. You take all decimals, all irrational numbers, every single thing within the gap. Okay, is what you're looking at. Now, when you are doing these probabilities, they're not going to be the probability of a single number or a group of whole numbers. They are going to be a range of numbers from 1 to 2, and you're taking every number between 1 and 2. 1.111, 1.1234, 1.5738, 1.943. All of those are going to be included from 0 to 1, or from 1 to 2. Okay. This probability is usually caused underneath or done underneath a density curve in which you find the area of said density curve. Okay. If you take the entire area of the density curve, it should equal 1. When we look at normal distributions and we start talking about z-scores and z-values and all that, they're going to be based on a density curve using continuous random variables. Now, we have this example. So we have this triangle up in the top corner, okay, and we want to find the areas. Now, if we look at the height has to be 1. And the reason the height has to be 1 is because base times height divided by 2 has to equal the area. The base is 2, from 0 to 2, that's 2. Multiplied by 1/2 gets us 1, so what does the height have to be to keep it 1? That would be 1. Simple algebra. So the height has to be 1 here so that the entire area is 1. Because if it's not 1, then it's not a probability that we're dealing with because it's not the 100%. Now, if we want to find the area of, or the probability of each section here, greater than or equal to 1, less than a half, 0, or between 0.75 and 1, we would find the area of said density curve of this triangle. So if we are greater than or equal to 1, then we're finding the area from 1 to 2. Which is half the triangle. So the length is 1, the height is 1, divided by 2 gets us a 1/2, so it's half. Now the next example, I guess C is the next one. I jumped down to D. C, if it's equal to 0, the probability is 0. You cannot have when you are dealing with continuous numbers, you cannot find the probability of an exact value. So you can't find what's the probability of 3. You can't find the probability of what is 1. You can't find the probability of 12. It can't be an exact. You got to find a range of numbers, because the exact, if you were trying to find, let's say, the area of this triangle at 1, what's the width of that at 1? It's 0. 0 times 1 divided by 2 is 0. So because the width is 0, you can't find an exact value. When it's continuous, you need a range of values. Okay. D is saying if it's less than a 0.5, but it's not equal to, that doesn't matter. Because again, it doesn't matter if it's equal to or not. The value at that point exactly is 0. So equaling that number or not equaling that number does not change the probability at all. And the last one is if it's between two numbers and you see it's not triangle anymore, and you might have to use a trapezoid formula, which is 1/2 b1 plus b2 times h. So you'd find the area of each section of each base, add them together, multiply it by the height. In this case would be 0.25, and then divide it in half. So the area would be 0.219. Now, for those, they should be 0, or not 0. They should be less than 1. My mistake. They should be less than 1 because the entire thing is 0. So if you ever calculate 1, you get like 1.3. You want to go back and check that calculation because there's something wrong there. All right, continuous versus discrete. Just a couple. Equals to inequalities do not matter in a continuous, but they do matter in a discrete. Okay, so a discrete that equal to an inequalities does matter. Discrete random variables are often described with a table or a histogram, while a continuous random variable is only done by a density curve. Okay, so continuous is a density curve, discrete is either a table or they're histograms. Okay, so they're bars. All right, so discrete random variables, we're looking at the mean in this case. So when we're looking at the mean of an event, which is denoted usually as mu sub x, okay, that's this little Greek letter here, that u, that is mu, mu. So if x is the event, then the average of it, or the expected, the mean of it, would be how many you would expect in that trial, okay? And that's how much it would be. Now, this is very complicated, showing you kind of the exact blah, 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 blah. Essentially, what you want to do when you're trying to find the probability of it, or the expected value, is that you would take the value, what x represents, multiply by the probability of that one occurring, and for each one, so for each x, you would multiply by the p-value, or the probability, and then you would add them all up. And when you add them all up, that's going to tell you the expected value of it, okay? And that's what all this is. This is just, the general formula, the fancy pants formula. You don't need to know what it is. It's probably on that formula sheet you need, but the expected value, you take the x value that falls into each bracket, multiply by its probability of each one, and then add up the entire group. Okay, the variance or the standard deviation. Okay, for those, when you're looking at that, what you're going to do is you're just going to calculate it like you normally would for a variance or a standard deviation, which would be taking the x value, subtracting it by the mean, so you'd have to calculate what the mean was, squaring it, and then multiplying it by the p-value. Okay, so x minus whatever the mean was that you calculated on the previous one, square that number, multiply it by p, and you do it for every single x, and then add them up. Now, on like an AP exam, you would not have a very large table for this because it just takes up too much time. You would have a smaller one to be able to do it by hand. You can also do this on a calculator. You just have to set it up with L1, L2, and find the probabilities and everything. Okay. The variance is if you just do that calculation. Remember the variance and standard deviation. Standard deviation, you just need to square root the variance. So whatever you get as your variance, take the square root of it, and that's your standard deviation. Okay. And again, fancy pants formulas. You don't have to worry about the fancy pants formulas if you can do it by hand. All right, so let's say we have a daily lotto. You pay $1 and you have a chance to win between nothing and $500, obviously. Or you lose $1, I guess, and you win $500. Those are the options. You pick a 3-digit number, and then a random 3-digit number is generated, and that's the winner. If we want to find the expected value, we'd have to, okay, what is the probability of us getting it wrong? Will it be 999 out of 1,000? Because there's 1,000 random 3-digit numbers. 000 up to 999. Okay, not no, 999. And so it would be 999 out of 1,000, and we would lose $1, so it'd be a -1. The probability of us winning, we would end up winning $499 because we put in $1. So if we wanted to gain the extra $1, it would be that way. And we have one chance out of 1,000 of getting it right. So we would multiply those two together and add them up, and we see we get a -1/2. So in the long run, if you kept playing this over a long period of time, this lotto, you would lose, it would average out to losing 50 cents. Okay, doesn't sound that bad, but you would lose 50 cents. Now, if we want to do the standard deviation, since -0.5 is the average, we would go -1 minus -0.5, -1.5. Square that, multiply it by 999 all over 1,000. And then we'd add it to 499 minus a -0.5 squared, multiplied by 1 over 1,000. And that gets us our variance of 249.75 and our deviation of 15.5. So that means that there's a chance that you would be either, from that -0.5, losing 50 cents, you could lose an additional 15.5 or 15.8, or gain 15.8 on top of that. And you'd be about 68% chance you'd fall into that range. So you see it's a very large spread there. You could lose $16 or you could gain a whole bunch of dollars. All right, that's the end of that section. Okay, very easy, very quick. And then we're going to be moving on to section 4. And after section 4, we're moving on to section 5, and then you're done.